Okay, so hopefully as we've been designing the system, you've noticed that we've been using layers of abstraction. So at the very lowest layer of abstraction, we had these bits moving across a wire, or a mailman, or a carrier pigeon, or a horse, or whatever. And then as we moved up to the next layer, now we had this local area network, or this apartment complex that we can talk to. And then we introduced a router or a post office that lets us talk between two different apartment complexes or local networks. And then we took a lot of post offices and chained them together. So now we have this whole network where we can talk to everyone in the world. So the moral of the story is we have all these layers of abstraction, and because of the way we've designed them, they're all sort of separate from each other. So maybe now at the lowest layer, instead of using pigeons, now I've changed and I want to use drones, or I want to use those little robots that roll around Berkeley and no one knows where they're going. So if I want to change to using those, that doesn't actually affect any of my decisions at the higher layers because everything is nicely isolated from each other. Or maybe in the layer with the post offices, now I want my post offices to work a little differently, or I want to build them differently. Well, that's okay. That doesn't affect the fact that I'm using pigeons or drones or anything. It also doesn't affect the messages at the higher layer. So all the layers are nicely separated from each other, and that's kind of a nice side effect of how we've designed the system. So now I'm going to, again, pass it over to Dave, who's going to go more into this idea of layers in the internet and how it's been designed.
All right, next big idea I want to show you from the internet is that of layering. Layering is an important part of how networks are constructed. To manage the amount of complexity in our networks is that the design is partitioned into layers. And each layer, you don't have one big, complicated, mega protocol thing that does everything. You build that up piece by piece out of layers. And each layer is a building block that provides some services and relies on services provided by the layer below it. So it relies on stuff provided by the layer below it and provides some more powerful services to the layer above it. So you could think of this in terms of, we use layering all the time in computing, right? Not just in networking. When you're building an application, you're probably also using some kind of layering. Like there's an operating system and there's an application, and the application is relying on the services provided by the operating system. And that's further, you can further decompose that. Like in the operating system, you might have like device drivers and you might have some actual physical stuff. And the device drivers are relying on the physical stuff and they provide services. And then, those are exposed through system calls, which provide a higher level abstraction. And then in your application, you might have a runtime library that's relying on system calls. So if you want to write a file, then you're actually calling a library that's responsible for figuring out what system calls to do to make the write to the file happen. And then there's the code you write. So each one of these is like some code that's like calling functions or relying on services from the layer below it and is exporting an API to the layers above it. Okay, so same deal in networking. Okay, so here's a kind of a standard model for layers in the internet. I don't need you to memorize this. You don't have to write it all down, but this is a standard way to think about or what the code that's happening in a network. It's kind of a lie, but it's kind of the truth. So don't take it too seriously. Sometimes called the OSI model, and it's not actually, we are actually deviating from the true OSI model, but close enough. So we have a bunch of layers here. There's a physical layer, which is like the electrons and that copper wire. There's the link layer, which is like the Ethernet that describes how you use that copper wire. There's this thing called a network layer, which is like the IP protocol I just described to you. There's a transport layer, which is building extra services on top of IP. Okay, so let's give you a little bit of an overview of each of the layers, and then we'll go into more details. Just to give you a map of, before I go into details on any of these layers, of the overall picture. The physical layer would be like Ethernet or Wi-Fi or semaphore flags or carrier pigeons or fiber optic link or something. So it specifies the physics. Like Ethernet would say, you have a copper wire And if the voltage level is, I don't know, 2 volts, then that means a 1 bit, and 0 volts means a 0 bit, or something like that. Okay? It would tell you how to interpret, translate bits to like voltage levels or the phase of a photon or some physics phenomena. Okay. Sorry, I lied a little bit. Yeah, it's kind of hard to separate the link and the physical layer, but the physical layer is like bits to like voltage levels, and the link layer would be like Ethernet, the part of the Ethernet that's responsible for doing what we did in the first slide of lecture, for figuring out which machine this is intended for on a shared network. On Wi-Fi, it might be when the Wi-Fi access point is using radio, so the way it's sending a message to your laptop is it's broadcasting a message, a radio message, and all of your laptops are hearing that, and each laptop is looking at that message and saying, is this for me, yes or no? Okay, so there has to be some way to indicate who it's for, so that's what's present at the link layer. The network layer, this would be basically the Internet protocol. Okay, so this is how we get a global network out of a bunch of these local area networks. So one thing this means is that each step along the way, a packet might get from the source to the destination by traversing 20 routers, 20 hops. Each one of those steps along the way might be potentially a different physical link layer. It might be that my machine is connected to an access point by Wi-Fi, and then the Wi-Fi is connected to a campus router through Ethernet, and then that campus router is connected to our ISP through fiber optic, and so on. Okay, so each one of those can be different, but the network layer protocol is the same. IP is the same.